Yeah, you should feel sorry for me now. As a quick refresher, as you're looking at multiplication, the trick for multiplication works with the following that I wrote up on the board. What you're trying to do is make sure that dimensions, specific parts of the dimensions match. In this instance, we have square matrices. Square matrices, you can always multiply them together. That will not be an issue. Works. 2 by 2, 3 by 3, 4 by 4, and so on. You can always multiply square matrices together. I'm sorry, same dimension square matrices. Yes, sir? Now, what you have to pay close attention to is if they are different values, you always want to watch the number of columns in the first one has to equal the number of rows in the second. If that occurs, you're happy. The result matrix will be the rows and columns that are left over. Okay? Now, my trick to doing these is that once you figure out what the new dimension of the matrix is going to be when you're multiplying, is to write out the first matrix, the column number of times it's going to have. Does that make sense? So what I wrote up on the board here, I says 3 by 2 and a 2 by 4. The number of columns match the number of rows. I know you guys aren't just copying your answers back there. And then from there, you wind up with a 3 by 4 as your final. That means I would write down this first matrix, the 3 by 2. I'd write that down 3 times in order to fill in all of my blanks. The book is very, very long-winded and annoying to read how they set this up. Every time I've ever read anything about trying to multiply matrices, it was the most difficult concept for me to grasp. Once I realized that this method works all the time, I was like, hallelujah.
Well, is there another way to do this?
Calculator.
Well, you said do it all by
Yeah, I mean, there is, when you say the number, you can match up rows to columns. It's a lot more tedious to go that route. This method is what seems to me to be a lot more seamless. It's just a little bit smoother.
Yeah, that's
Did we multiply matrices before?
I heard you might have. Okay, I've heard you've done a little bit of this.
We did like the adding side of the measure.
Okay.
You might have
You might have done this scalar.
by an integer, but
Okay.
we'll multiply it.
Okay. So in this case here, guys, when we get back to this, once again, you just write down that first matrix. Twice. And from there, I'm going to fill in with my columns. Start with the top left. Go to the next number, the bottom left. Go to the next one, 4. And then last but not least, the 3. From there, now you have 4 simple addition multiplication problems to create your new matrix. And you're going to wind up with 6 plus 10, negative 15. Hey, did we do this one in our notes?
Yeah.
Convenient, wasn't it? Okay, that's how it works. Now, when we take it a step further, when we take it into the different dimensionals, that's when you just have to be a little bit more careful. Now, in this example, when you're looking at it, we have matrix A and matrix B. Matrix A has 3 rows and 2 columns. Do you agree?
Yeah.
It's a 3 by 2. Do you remember how to check to see what the dimensions look like on your calculator and make sure that you know which ones you're doing first? Remember, if this is a 3 by 2 or is it a 2 by 3, you can always go to your calculator. Go to the matrix button, second matrix, and just type in 3 by 2 and see what shows up on the screen. Is it lengthwise or heightwise? Yes, sir.
Rows and columns?
Yes. It's opposite than what you want to say because you want to be alphabetical. Slowest thing in the world to load.
How does those balance actually? Because it's how that's going the largest count.
Sooner or later it'll show up on the screen. Hello, computer. Whatever. Anyway, so if you press some buttons on your calculator, you'll be able to tell which way it goes. So this one is a 3 by 2, and the other matrix is 2 by 2. You agree? Do those numbers match?
Yeah.
Okay. Those numbers match, which means your result matrix is going to be a 3 by 2. Which means how many columns will the new one have? 2 of them. How many times should I write down that first matrix? Twice. Remember, always write it down the number of column times. If this is going to be a 3 by 2, the new one's going to have to be, that means you have to write it down twice. So you write it down twice. Let's see, it's -2, 3, so it's -2, 1, -4, 6, and 0. And the other matrix was -1 on the first column. -2 in the second column. -3 and 4 respectively for the last ones. And now your result matrix is going to have 3 rows and 2 columns. Two plus -6. -1 plus 8. -6 and 0. -6 and 12. 3 and -16. And 18. Follow the pattern of how many times you have to write something down, and it flows really, 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 really nice. Okay? Not so scary? Now, when it comes down to the types of stuff that I'm hoping that you'll be able to do by hand, it's going to be these 2 by 3s, 3 by 2s, things like that. Anything bigger than 2 by 3s or 3 by 2s tend to become really tedious, and that's not what I want you to be able to worry about by hand. Then we'll start to open those up more for the calculated portions. But 2 by 3s, 3 by 2s, that's about the brunt of the by hand stuff. Does that make sense? Does that seem fair? Now, the other thing that you can do with matrices, and I know this came up a little bit, not so much in this class, but it did come up. Or do you want to try one more on your own real fast? All right, try one more on your own real quick before I go on to the next part here. Can you see that when you're blowing? I'll blow up a little bit more. Remember, when you start with this, always identify your dimensions first, and then work from that spot. Oh, let's see. Oops. -3 and -6 is -9. 3 and 4 is 7. 2. -3, 2, and 1. It's very easy with these values when you start writing all these numbers in. If your handwriting is subpar, you'll get lost in your handwriting.
What do you mean if you're going to do
If that is me, and that's the other thing that can happen. Okay, so you just gotta be very careful where you're writing stuff out. You can get lost in your handwriting if you're careful with those numbers. But the pattern itself isn't so bad, is it? So guess what you can do with these things? No, we'll wait. I think we'll wait on word problems till next week. You'll be able to do word problems. They're very easy.
How do you do word problems with matrix?
They're used for costs and inventory. It's very simple to set up. Yes, ma'am.
How do you know what order to put stuff in parentheses?
You always start at the top. You always start at the top left and work your way down the columns. Start at the top, go to the, and if there was 3 rows, you'd go all the way down all 3 of them and just continue to go down. It's a little bit backwards from how you would read it. Excuse me, but that's the pattern you follow. Okay?
Are you ever gonna have a second or that doesn't make sense?
Glad I could answer that question. It was the easiest one all day. Yes, sir.
Can you go into like the first one?
What's that?
Like the first set of the first matrix. Why you like put it in there 2 times?
You put that in because what I'm showing you guys here is a method that I've used over the past few years to help students multiply these things by hand a lot easier, because there is a pattern to how it works. And what I'm doing here is describing the pattern to which you would multiply these to make your lives easier. There are other ways of going about explanation here, but what happens every time you multiply matrices, if your matrices, in this case, was a 3 by 2 and a 2 by 2, oops. If those 2 values match up, that means the result matrix is going to be a 3 by 2. That result matrix has 3 rows and 2 columns. So my next step is to always write down this first matrix that many times. By doing that, my pattern of just following the columns works. Okay?
What do you do if it's not the same?
You can't multiply them.
No solution.
Yeah, you can't do it. If it was a 3 by 2 and a 1 by 2, you can't do it. Go to the next problem. Say, sorry, Murphy, not happening. Maybe tomorrow, but not today. Not gonna day. It's not prudent at this juncture. You have no idea what I mean.
What is that from?
It's George Bush the First. 4.3. What I wanted to blend today with the some simple, a little bit larger scale multiplication is also going to blend in what are going to be called determinants. Determinants are going to be used primarily next week to solve systems of equations. And it is a very easy process to do so. It's good thing he's got a helmet on. It's a very easy process to solve for determinants, but once again, it's a pattern that we have to follow, and it's watching your signs. Okay? It's watching your signs. So determinants are going, like I said, determinants are going to allow us to solve systems very, very, very easily, especially large systems. 2 by 2s have always been pretty simple to do by hand, whether it's a system of equations with 2 variables, 2 equations, pretty easy by hand. When you got to the 3 by 3s, you guys got mad at me, and it was simple to get lost in them. When we get to the 3 by 3 stuff, now, once I show you guys how to use determinants, you're going to see how you would have really liked to know how to do that.
Yeah.
It's just like everything. You guys had to learn how to add before you can multiply, right?
But multiplying isn't easy.
Yes, it is.
You want to add 2 plus 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 2, or take 2 times 8.
Never mind.
Counter example. How you like that?
No, explain to me.
Because I'm awesome. Anyway, determinant. What we're going to do today is work with determinants of square matrices. This only is going to work with squares. Okay? We don't do determinants as far as odd-sized ones. It doesn't follow any pattern. The reason why we're working with square matrices is because once we get into our solving of systems, if you have 2 equations and 2 variables, it's a 2 by 2 matrix. If you have 3 equations and 3 variables, it's a 3 by 3 matrix. The answer part comes into play later. So yes, there is that 3rd or 4th column respectively, but that will come in later. So what we're looking at being able to do here is follow this pattern. For example, what you will see is, let's say you have matrix A, and we'll make it real easy. 1, 2, 3, and 4. And I want to find what's called the determinant. A lot of times you will see the determinant written, you will see it written like this, the DET of A. You might see uprights, you might think of absolute value, but it's not. Or you might see the uprights around the matrix itself, instead of brackets, they will throw uprights on there to show that you're finding the determinant in this case. So the determinant works with basically your downward and your upward diagonals. We all want to slide down a slide. We don't want to climb the stairs, right? If it was a 20-foot slide, would you rather just start at the top without having to climb the stairs and then just slide down and go whee?
Yeah.
We always.
Take the elevator.
I'd rather take a slide.
So what happens here is you always work with your down. You always start with your downward diagonals, and you work your way down. And you wind up with 1 times 4, and to that you subtract the upward diagonal. 3 times 2. The point of doing the determinants is that you're going to use it to solve systems. We just have to learn how to do it first. Okay. Next.
Why does it matter about the direction?
They're looking for the difference between the downwards versus the upwards. And you're right, your science, you still have that subtraction part. So we have negative determinants. Okay. And it allows us to solve systems. Give me a couple of days and you're going to go, oh yeah, this makes life so much easier. Yes, sir? I'm getting there. I'll show you how it works. It's very easy. You just have to be careful not to mix up which direction you're going. But we're going to work with 2 by 2 to start with. So in this case, you wind up with 4 minus 6, otherwise known as negative 2. Yep.
So is that what the debt thing is?
Yep. It's out of money. Debt of it.
Wait, what is that? What does that actually do something for?
Like I said, for right now, all I'm doing is calling this the determinant. Next week, maybe even today if we have a little bit of time, you will see how the determinant is used to solve systems. And then once you solve systems using determinants, you're going to get mad at me because it's really easy. Okay?
So we have to do this like this, if I don't change it.
Okay? So let's look at another one. Oops. Once again, I have a square matrix, 2 by 2, and I want to find the determinant of this. When I go to find my determinant of this, remember you start with your downward diagonals, and you subtract the upward diagonals. So our determinant is? Very good. 2 by 2s are a piece of cake. You'll be able to do them in your head. Watch your signs. That's the only thing I can tell you. Watch your signs when you're subtracting with negatives and all that kind of junk. Yes, sir? Positives and negatives?
Oh.
It's opposite over hypotenuse also, depending upon what type you're looking at, or it could be a stop sign. You guys are English people, right? A lot of you guys are good at English and writing and stuff. All right. I need you to figure out how to write. I've never been able to figure out how to write this sentence down. I can say it, but I don't know how to write it. There are 3 2s in the English language. How do you write down that sentence?
I remember this from
You cannot change the vocabulary from that specific statement. You cannot add words. You cannot take words away or anything.
You have to write it like
You have to do it.
You have to
no,
do it
like
in
you have to write it in a.
Which one?
all
The
3.
two.
It's all-
But you can't put that. But you're putting more words in that sentence.
No.
Well, you
no,
can't.
What if you
replace
put,
it.
what if you
Say 2.
put, write out?
You guys are too smart for me.
Write out the
All right, hold on. Shh, hold on. What were you? Go on. Go
You
ahead.
have to do the phonetic spelling of all 3, which is the same for all 3.
Right.
Which is probably just T-O.
Right.
So,
Which is what I meant.
right T-O.
Except that like There are special symbols to me, so it's like.
You would have to do the
This is the most answers I've ever had to this question. These kids are smart.
Just write it down.
There are 3 twos in English language. I write that down. They started talking about phonetics. No. Let's look at a 3 by 3. And like you said, what happens with the 3 by 3? It's okay. Hold on. Take a deep breath. Take a deep breath. When you have a 3 by 3, yes, it looks really weird and it's scary, but it's okay. When you are working with a 3 by 3 determinant, what happens here is now you have 3 downward diagonals and 3 upward diagonals. And what you have to do is you take the sum of both of those parts and then find the difference. So here's what occurs. I know it's kind of difficult what they did here is that they just started with the 3 diagonal part. From there they went to the 2 diagonal, added the straggler. Went to the single one, added the double. So you get those 3 pieces. And then they work themselves backwards. I've always found that it's easier for me to walk you through a couple of them numerically, and you will see the pattern that evolves. 3 by 3s are not that bad once you do a couple of them. So what I want to do is start with this. Don't worry. I want to start with this example. 4, 2, negative 1, 1, 1, 0, 2, negative 3, 5. Now, what I'm going to do is start with my diagonals. I start with my downward diagonals to begin. I've got those 3 right away. 4 times 1 times 5. Okay. I go to my next diagonal. 2, 0, and 2. To see how I'm going, and you have to have 3 numbers in a line. What happens here is that if I replicated this column, if I replicated that column, I'd have 4, 1, 2. Do you see how now that 2 winds up on that diagonal by moving it outside? And that's how you start to get these through. So we start with 4, 1, 5, 2, 0, 2. And then I do the same idea of this replication of moving a column out. 2, 1, negative 3. Now, once again, as I go through those, I have that 3 in a row. You don't need to replicate columns outside of a matrix if you don't want to. I rarely, if ever, do. I know that I have to have 3 in a row. So if I start with all 3, I'm good. Start with 2, I need the single. Start with 1, I need the other 2. And it works going downward, and you do the same thing going upward. Yes, sir?
How many diagonals?
3. If it's a 3 by 3, you will have 3 diagonals. If it's a 2 by 2, you will have 2 diagonals. Excuse me. If it's a 3 by 3, you will have 3 of them going downward. If it's 2 by 2, you only have 1. So I misspoke.
What's the answer?
So then it doesn't matter where in the drawing it's like.
As long as if you started here with 2, going to the 2, 0, 1, negative 3 to the 1, 4, 1, 5, you're going to get the same result when you have it again.
So will the answer be 15?
I don't know, I'm not there yet. So then we had, Mr. Connors, I saw you had your hand up. What's up?
What about the 1 and the negative 3 and the 2?
Down here?
Yeah.
Once I take this one? Okay. This was my first diagonal.
Yeah.
The 2 and the 0 with this 2 was part of the second one. And then the negative 1 with the 1 and negative 3 was the third group.
So we could do it with the 1 and the negative 3 and 2.
No. Because in the order in which we are going, we work our way up That's how we set these things through. Okay? So we always start working our way up the line, and then we work our way down the line. Okay? So what we do is we figure out the sum of all of our upward diagonals, 20, 0, and 3. I'm getting 23. To that, I have to subtract. Notice I put a bracket there.
What?
Because there are going to be 3 addition problems, I guarantee you will only subtract the first part, and then you'll add in the other ones. So go back, clean up my matrix, work with my upward.
So when we're going up, we start with the bottom and go up.
2, 1, negative 1. Negative 3, 0, and what goes with that? Good. And then lastly, I get 5, 1, and 2. Now, once again, the reason why I put these brackets here is that I have to take the down diagonal and subtract the up. So I have to find the sum of all those and the sum of all of those before I do that. What you guys will wind up doing is you put the string of those values together and you'll hit subtract, and the only one you're going to subtract is just this first value. And then you'll wind up adding the other ones in. So you got to be careful when you set these things up. Find all the down diagonals, find all the up diagonals, then find your difference. Take an extra half a second to split it apart. Yes?
So when it's down, you go up, and it's up, you go down.
Huh? When you're going down, yes. I see what you're saying. Yes. It works for his brain. I know what you mean. That works. Now, in this case here again, once we get to this part, we know we have 23 minus, this is negative 2, a 0, and a 10. So I get 23 minus 8, otherwise known as, and that's the determinant.
What would we write determinant of?
Determinant of A is 15. So if it's just, what the problem going to look like is find the determinant of A. Or it'll have these brackets around it. That's what it'll say. As we get into these things, I can't imagine doing any determinants, to tell you the truth, any larger than 3 by 3. You could go 4 by 4s, but there's a calculator for that.
Wait, there's a D function in the calculator?
Yeah, the calculator?
Yep.
Arwe Akute Ikte Adelaide Ude
Who? If I were, I have something fun of that, I can.
I should do that someday. Talk to Pig Latin. I probably am talking to Pig Latin to some of you guys anyways. We're teaching this stuff, so. Let's try another one. Let's try another one of these. So I have a 3 by 3 and I want to find the determinant. I'm going to start, once again, we always start with our downward diagonals. As I start with my downward diagonals, we have 2, 0, 4. To that, I'm going to add what?
Negative 1 times 2 times 1.
Negative 1, 1, and 1. And then once again, I add that to, Mama, I think you mumbled it.
Yeah.
Okay. So now all of my downward diagonals gives me a sum of negative 13, yeah. We agree? All right. To do that, I have to subtract all the upward ones. So my upwards, 103. What's the next one?
Could you do negative?
212. What's that?
Could you go the other way, like negative 2 times?
And then lastly,
4 negative 2 negative 1.
0 minus 1 minus 4 minus 0.
do you see how a 4x4 would just be unbelievably tedious?
Yeah.
Not very difficult, but it's tedious. So we end up with negative 13 minus, hey, at least Mom made you happy with the color scheme.
I see what you mean.
0, 4, and 8.
Dude, November, I think it's like November 10th, something like that, they play. The good team versus the best team.
Isn't it awesome? You already found the button, didn't you? Hey, guess what? There's a button for this.
There's a button for that.
I don't know why mine doesn't want to fire up. But yeah, there is a button on your calculator. Remember, as I've been saying along, in this chapter there will be calculator, non-calculator portions. As we get to the point of solving systems using determinants, we will probably be using our calculators because it's a lot quicker. Now, what I'd like you to do again is let's create a matrix. Remember how we created matrices?
Second matrix.
Second matrix, and let's see, we have a 3x3 here, okay? We'll use the example we just did. So what I want to do is I want to edit my matrix A. I'm going to turn this into a 3x3. And now I just have to overwrite all the information that's in there. I start that by just going, the calculator will read through the rows. 2, negative 1, 3, negative 2, 0, 1, 1, 2, 4. Back out. Now what I want to do is go back to the matrix button. If you scroll over 1 to where it says map, D-E-T. What do you think that stands for? Determinant. We want to do the determinant of matrix. Go back to your matrix. A. And guess what button you press?
Equals 0. Wait, if we do that, we don't have to show work on like tests and stuff. We just type that and we just put the answer.
Correct. Now here's the thing.
He wants to write it out anyway.
Here's what's going to happen. You are going to use the determinant to solve stuff later. So you need to know how to find it. On the test quizzes, there will be calculator, non-calculator. I will ask you to crank out a determinant of a 3x3 by hand. The other part, you'll be using the determinant to solve systems of equations. I don't want you to do that by hand because it takes too long.
Right.
Because you'll be able to store value in your calculator to solve systems with that. The reason, like I said, the reason that's why we were using the determinant is because it solves systems. Running out of time to talk about this one.
Oh, sorry.
You may use the determinant also to find the area of a triangle. Obviously, the area of a triangle, you will be giving coordinates. There's a simple formula for this in your book. I'm going to give you one problem to try at this. Let me explain one thing about this. The reason why they write plus or minus 1/2 in front of the determinant there is because you guys notice how sometimes we had a determinant that wound up being negative? And you have a negative area. That alleviates that. So let's say your determinant was 10. You take positive 1/2 of it, you get the area to be 5. Yes, sir? You can just hit,
Second mem. And then
yeah, you can wipe the whole thing out by hitting the second memory, the plus sign, 7, 1, 2. That'll restarts the whole thing. But if you have to clear it out, your best bet is just to go in and just delete. It's easier to hit your second memory, 7, 1, 2, I believe, or is it 7, 2, 2? That'll just, yeah, so 7, 1, 2 wipes, 7, 2, 2 resets. Yeah. Second, memory 712 wipes out all of your stored
It
matrices.
doesn't matter, because when you fill it in, you can just.
Yeah, 'cause you can also overwrite it. But what happens though sometimes if you're not careful, you can make a simple mistake. But like I'm saying, we'll talk a little bit more about this stuff on Tuesday because we're running a little short here. But take a look at this. I want you to try one of these because I think I only gave you one of them. So let me double check. This should be good to go. Let me double check the on the 218 stuff.
Back to your matrix.
Yeah, let's just do this. There, I cut some stuff down. Okay? So it's 30 through 34, and then it's 30 through 34 all, and then 16 through 30 evens. Okay? The 12 stuff, the 212, that is still doing some multiplication. But what I've done with those problems is something a little bit different. In those problems, what's nice about the book is that it throws in some scalar stuff as well as some order of ops. Also, there's I think there's a couple of questions that you're using multiplication to solve an equation. You follow the same pattern as you would with your how the matrix stuff sets up, and you're going to be pleasantly surprised as to what your solutions will be. All right? We'll finish off determinant stuff on Tuesday. We will start talking about what's called Kramer's rule on Tuesday as well. That's the second half of this section 4.2, second half of 4.3, and that'll get us into our first sets of systems. Okay? Yes, sir. Do I still have?
Friends.